The mayfly is born into time, but it does not belong to it. Among all insects, few embody the paradox of existence as completely as the mayfly, a creature whose adult life is so brief that it is measured not in years, months, or even days, but in hours. To human perception, this brevity suggests fragility, insignificance, even tragedy. Yet in the language of evolution, the mayfly tells a very different story, one of endurance, precision, and remarkable success. The origins of the mayfly stretch back more than 300 million years, predating dinosaurs and flowering plants. Fossil records reveal forms strikingly similar to those alive today, a testament to an evolutionary design so effective that it required little alteration. While countless species rose and vanished, the mayfly persisted, quietly refining a life strategy built around patience and restraint. Its survival did not depend on speed or aggression, but on timing. For most of its existence, the mayfly lives unseen beneath the surface of freshwater rivers and streams. As a nymph, it spends months or even years clinging to submerged stones, burrowing into sediment, or drifting gently with the current. In this hidden world, time flows differently. The nymph feeds, grows, and molts repeatedly, accumulating energy for a future it has never experienced. This underwater phase represents the true life of the mayfly, a prolonged preparation for a single, irreversible moment. Physically, the mayfly nymph is built for stability and efficiency. Its flattened body reduces resistance against flowing water, while clawed legs anchor it firmly to rocks. Gills, arranged like delicate fans along its abdomen, extract oxygen from moving water, allowing respiration even in low-oxygen environments. Every aspect of the nymph's form reflects adaptation to a world defined by current, pressure, and persistence. During this long juvenile stage, the mayfly becomes an integral component of freshwater ecosystems. By feeding on algae, detritus, and microscopic organic matter, it contributes to nutrient cycling and water clarity. It also serves as a vital food source for fish, amphibians, and other aquatic predators. Entire river systems pulse in rhythm with the presence of mayfly nymphs, even though they remain largely invisible to the surface world. The transition from water to air is not gradual, it is abrupt. At the moment of emergence, the mayfly abandons the environment that sustained it for most of its life. Rising toward the surface, the nymph splits its exoskeleton and emerges as a winged form known as a subimago, an intermediate stage unique among insects. This transformation is both miraculous and perilous. The mayfly is suddenly exposed to gravity, wind, and predators it has never encountered before. The subimago is not yet fully mature. Its wings are opaque, its flight weak. Within hours, it will molt once more, becoming the adult mayfly, or imago. This final molt marks the beginning of the end. The adult mayfly does not eat. Its mouthparts are reduced, its digestive system largely non-functional. All remaining energy is devoted to a single purpose, reproduction. The adult mayfly exists in a state of urgency without panic. It flies, mates, and dies, often within the span of a single day. In some species, life lasts only minutes. Yet this brevity is not failure, it is optimization. By compressing adulthood into such a narrow window, the mayfly minimizes exposure to terrestrial predators and environmental hazards. It does not linger, it completes its role and disappears. As dusk settles over rivers and lakes, swarms of mayflies rise into the air, forming clouds of delicate motion. To observers, these events appear chaotic, even excessive. But within the swarm lies order. Males detect females through subtle visual and chemical cues, mating occurs mid-flight, and eggs are released back into the water below. The cycle closes almost as soon as it begins. The mayfly's story is not about how long a life lasts, but about how precisely it is lived. In its quiet, fleeting presence, the mayfly demonstrates that survival does not always favor longevity. Sometimes, it favors timing. The mass emergence of mayflies is one of the most synchronized biological events on Earth, a phenomenon so precise that it can transform entire landscapes within hours. Rivers seem to breathe as thousands, sometimes millions, of individuals rise simultaneously from the water's surface. This is not coincidence. It is timing refined by evolution, a collective decision encoded not through communication, but through shared environmental cues. Temperature, daylight length, water chemistry, and flow rate all converge to signal the moment of emergence. When conditions align, entire populations respond as one. This synchronization overwhelms predators through sheer abundance. Birds, fish, spiders, and bats feast, yet they cannot consume more than a fraction of what appears. The strategy is simple and devastatingly effective: survival through excess. By emerging together, mayflies ensure that enough individuals survive to reproduce, regardless of how many are lost. This phenomenon reveals a deeper truth about the mayfly's life strategy. Individually fragile, collectively unstoppable, the mayfly does not invest in defense or aggression. It invests in numbers and timing. Each individual is expendable, the lineage is not. This perspective challenges human ideas of survival, where individual longevity is often prioritized. In the mayfly's world, the continuation of the species outweighs the fate of any single life. Flight, though brief, is a marvel of engineering. Mayfly wings are thin to the point of translucence, yet reinforced by an intricate network of veins that balance strength and flexibility. These wings are not designed for long-distance travel or maneuverability. They are optimized for short bursts, vertical ascent, and controlled descent. The mayfly does not explore the sky, it uses it. Vision during this stage is specialized for one task: locating mates. Large compound eyes, particularly pronounced in males, detect movement and silhouette against the sky. Females are identified not by color or pattern, but by flight rhythm. A single miscalculation can mean failure, yet the simplicity of the system reduces error. In the chaos of the swarm, precision emerges from uniformity. Sound, too, plays a role. The collective wing beats of a mayfly swarm create a subtle acoustic signature, a hum that draws predators and signals abundance. What seems like vulnerability is again turned into advantage. Predators distracted by the swarm are less likely to target specific individuals. The mayfly does not hide from danger, it saturates it. Once mating is complete, females descend to the water, releasing eggs in direct contact with the surface or while skimming just above it. Some species dive briefly beneath the surface, risking immediate death to ensure egg placement in optimal conditions. These eggs sink, adhere to substrate, and begin development almost immediately. There is no protection, no guarding. The river itself becomes the nursery. Mortality at this stage is extreme. Floods, droughts, pollution, and predation eliminate vast numbers of eggs and nymphs. Yet this vulnerability serves as an environmental filter. Only rivers capable of sustaining mayflies can host them. In this way, mayflies act as biological indicators. Their presence signals clean, oxygen-rich water. Their absence warns of ecological imbalance. As nymphs grow, they interact continuously with their surroundings. Some species burrow into sediment, others cling to stones, and some swim freely in open water. Each lifestyle reflects a response to current speed, substrate type, and predator pressure. Diversity within the mayfly order is not random, it is sculpted by the physics of water itself. Energy efficiency governs every stage. Nymphs feed constantly but selectively, maximizing intake while minimizing exposure. Adults expend energy only once, in flight and reproduction, after which depletion is absolute. There is no recovery, no second chance. This irreversible design removes indecision from the equation. The mayfly's life is a straight line, not a loop. Human observers often romanticize the mayfly's short adult life, interpreting it as a metaphor for impermanence. While poetic, this view misses the biological reality. The mayfly does not experience loss. It does not measure time. It fulfills a function with precision, then ceases. From an evolutionary perspective, this is not tragic. It is efficient. As night falls and swarms disperse, the river returns to its quiet state. By morning, most adult mayflies are gone, their bodies scattered along banks and water surfaces, returning nutrients to the ecosystem. Fish feed on them, microbes break them down, and the cycle resets. What remains unseen below the surface is far more enduring, the next generation, already developing in silence. The mayfly's impact is disproportionate to its lifespan. In a single emergence, it can feed entire predator populations, redistribute nutrients, and mark seasonal transitions. It is both event and process, moment and mechanism. Its life may be brief, but its influence lingers long after its wings have fallen still. Beyond their fleeting appearance above the water, mayflies function as quiet engineers of freshwater ecosystems. Their influence begins long before their wings ever touch air. As nymphs, they spend the majority of their lives processing organic material that drifts through rivers and streams. By grazing on algae and decomposing plant matter, they regulate microbial growth and prevent excessive buildup that could otherwise suffocate aquatic systems. This constant, low-level maintenance keeps water clearer, oxygen levels higher, and habitats more stable for countless other organisms. The movement of mayfly nymphs across riverbeds subtly reshapes their environment. Burrowing species aerate sediment, allowing oxygen and nutrients to penetrate layers that would otherwise remain stagnant. Clinging species influence biofilm distribution on rocks, indirectly shaping which microorganisms dominate a given stretch of water. These effects are not dramatic, but they are cumulative. Over time, rivers inhabited by healthy mayfly populations develop different chemical and biological profiles than those without them. Because of this sensitivity, mayflies have become one of nature's most reliable indicators of environmental health. Their nymphs require clean, well-oxygenated water and are highly vulnerable to pollutants such as heavy metals, agricultural runoff, and industrial waste. Even slight changes in water chemistry can disrupt the development. When mayflies disappear from a river, it is rarely an isolated event. It is a signal that the system itself is under stress. Human activity has placed this signal under increasing pressure. Urbanization alters water flow, replacing gradual seasonal changes with sudden surges that wash away eggs and nymphs. Dams disrupt temperature patterns and sediment transport, fragmenting habitats that once functioned as continuous nurseries. Agricultural chemicals enter waterways invisibly, accumulating in sediments where mayfly nymphs feed. The result is often a silent collapse, noticed only when emergences fail to occur. Yet mayflies also demonstrate resilience. In regions where conservation efforts restore riverbanks, reduce chemical use, and re-establish natural flow patterns, mayfly populations often return. Their rapid reproductive cycles allow them to recolonize recovering habitats quickly. In this way, mayflies serve not only as warnings, but as measures of recovery. Their reappearance marks a system regaining balance. Climate change introduces a more complex challenge. Rising temperatures can accelerate nymph development, shortening growth periods and reducing body size. Altered rainfall patterns affect water levels and current speed, disrupting the cues that synchronize emergence. When timing shifts, mayflies may emerge earlier or later than predators expect, temporarily altering food web dynamics. Some species adapt by adjusting life cycles, while others decline, unable to keep pace with environmental change. The relationship between mayflies and predators illustrates the depth of their ecological integration. Fish species time their spawning and feeding behaviors around mayfly emergences. Birds migrate or adjust foraging routes to exploit these seasonal events. Even terrestrial ecosystems feel the impact as mayfly bodies accumulate along riverbanks, transferring aquatic nutrients to land. This cross-boundary exchange enriches soils and supports plant growth, linking water and land through a single insect's life cycle. Scientific research increasingly views mayflies as model organisms for studying ecological connectivity. The dual existence, long underwater development followed by brief aerial adulthood, bridges environments that are often studied separately. Through mayflies, researchers trace how changes in water quality ripple outward, affecting organisms far beyond the river itself. Despite their importance, mayflies rarely command attention. They lack the visual drama of large animals and the persistence of long-lived species. Their value lies in consistency, in the quiet repetition of a cycle that has sustained ecosystems for millions of years. When that cycle breaks, the consequences unfold gradually, often unnoticed until damage becomes widespread. In observing mayflies, one begins to see ecosystems not as static backdrops, but as processes in constant negotiation. The mayfly is both participant and messenger, shaping its environment while reflecting its condition. It does not resist change aggressively, nor does it endure neglect indefinitely. It responds, and through its response, reveals the state of the world it inhabits. As rivers continue to change under human influence, the fate of the mayfly becomes intertwined with our own relationship to freshwater. Their presence reminds us that clean water is not an abstract ideal, but a requirement written into the lives of countless organisms. Where mayflies thrive, systems function. Where they vanish, imbalance follows. In evolutionary terms, the mayfly represents a philosophy that feels almost foreign to modern thinking. It is not designed to persist as an individual, to accumulate experience, or to adapt through learning. Instead, it embodies continuity through replacement. Each life is brief, but the pattern is enduring. Generation after generation, the mayfly repeats the same sequence with extraordinary fidelity, proving that survival does not always require innovation, sometimes it requires consistency. This strategy has allowed mayflies to remain largely unchanged while the world transformed around them. Continents shifted, climates oscillated, and dominant species rose and fell. Through it all, the mayfly persisted, anchored to freshwater systems that themselves evolved slowly and predictably. Its dependence on clean water bound its fate to stability, and in turn, it rewarded that stability with ecological balance. The mayfly's relationship with time challenges human intuition. To us, a life measured in hours feels incomplete. To evolution, it is sufficient. The mayfly invests its energy not in duration, but in precision. Every stage of its life is optimized for its role, from the patient growth of the nymph to the explosive brevity of the adult. There is no excess, no hesitation, no redundancy. The mayfly does not outlive its purpose, nor does it fall short of it. As environmental pressures intensify, the mayfly's future becomes a measure of our own choices. Rivers that remain clean, connected, and seasonally stable will continue to host these ancient insects. Those altered beyond recognition will not. The mayfly cannot negotiate with pollution or adapt quickly to toxic conditions. Its disappearance is not dramatic, but it is definitive. When mayflies vanish, they take with them a signal that something fundamental has been lost. Yet there is resilience embedded in the design. Where restoration occurs, where waterways are given space to recover, mayflies often return. Their re-emergence is quiet, easily overlooked, but deeply significant. It marks not just the return of a species, but the reactivation of an entire ecological process. The river begins to function again, not as a conduit, but as a living system. In this sense, the Mayfly's brief flight is not the end of its story, but its most visible chapter. The true narrative unfolds underwater, unseen, sustained by currents and sediments, by patience rather than urgency. What rises into the air is only the final expression of a life already lived in full. As evening light fades and the last mayflies settle onto the water's surface, their wings become still. Within hours, they will be gone. But beneath the riverbed, life continues uninterrupted. Eggs develop, nymphs grow, and the cycle resets with quiet certainty. The mayfly does not mourn its passing, nor does it celebrate its arrival. It simply fulfills a role written long before memory. In watching mayflies, we are reminded that longevity is not the only measure of meaning. Impact does not require permanence, and significance does not demand visibility. Some lives shape the world not by lasting, but by happening exactly when they are needed. And so the mayfly endures, not in the air, but in the flow of water, in the rhythm of seasons, and in the ancient agreement between life and time.